On the 24th of April 1990, Space Shuttle Discovery launched the Hubble Telescope into orbit. This was an exciting time for space exploration, as Hubble promised to produce mind-boggling images, showing us an early view into our universe. After 30 years of service, Hubble has done exactly that. Throughout its lifetime, Hubble has taken millions of amazing pictures. Despite becoming the most famous telescope in the world, it's easy to forget that it was almost a complete failure. Soon after it launched, scientists discovered a small defect in Hubble's mirror, which caused it to produce extremely blurry images. This 2.5-meter mirror is the heart of the telescope. It needs to be shaped perfectly in order to produce the highest quality images. The main mirror captures the light before reflecting it onto a much smaller mirror. From here, the light is reflected onto Hubble's various imaging instruments. If the mirror's curve was perfect, light that hits any part of the mirror would focus exactly onto the same spot. However, due to the mirror's defect, light hitting the inner parts of the mirror was being focused on a different place. The shape of the mirror was only off by 2,000 nanometers, 1/50th the thickness of a human hair. But it was enough to render Hubble completely useless. The mirror in question was built 10 years before Hubble launched and went through years of testing. What most people don't know is that an identical backup mirror was also made in case the main mirror ran into any problems. So how did this flawed mirror manage to make its way into space? And why wasn't the backup mirror ever used? In 1977, NASA received the funding it needed to start building the Hubble Telescope, expecting it to cost around $300 million. They contracted the optics company Perkin-Elmer to design and build the telescope's main mirror. They were NASA's top choice because they intended to use custom-built computer-controlled polishing machines to grind the mirror into its required shape. This technology was literally cutting edge at the time. After all, the mirror had to be polished down to an accuracy of just 10 nanometers. But in case they ran into any problems, NASA asked them to subcontract another company to make a backup mirror. They chose the company Kodak, known for making camera equipment and optical lenses.
For clear, colorful, lasting pictures, be sure you use Kodak film. It does make a difference.
At the time, Kodak suggested that both companies should cross-examine their mirrors to check for any problems. This did not happen. With NASA's budget secured for Hubble, Perkin-Elmer went ahead with their design and began building the mirror in 1979. They started with a blank sheet of ultra-low expansion glass and began carefully polishing it down to the intended shape. This process was painstaking, and it took 2 years to finish. The glass was then washed and covered with a reflective aluminum coating, and so the mirror was born. Over the next few years, the mirror went through a series of tests to show that it could handle the intense vibrations of a rocket launch and survive the harsh conditions of outer space. But in order to test if the mirror had been polished to the correct shape, they used something called a null corrector. This was essentially a special lens with a series of mirrors used to make sure that the light hitting Hubble was being focused correctly. A laser was shined through the null corrector and a lens which contained a wavefront. If everything was perfect, the lines from the wavefront would look perfectly straight, with no contour lines. However, as the engineers were setting up the null corrector, one of the mirrors was wrongly positioned, and it perfectly canceled out Hubble's flaw. This caused the results to show that Hubble's mirror was in fact perfect, when it most certainly wasn't. At the same time, Kodak was nearing the completion of their mirror. But since NASA had chosen to go with Perkin-Elmer, Kodak's mirror was left without its reflective coating and put into storage. This tiny error made its way through the testing program, and in 1990, the telescope finally launched. It didn't take long for the scientists to realize that something was very wrong. The first images received from Hubble were blurry and clearly showed that the telescope was not performing correctly. For the engineers, this was a crushing blow. After decades of work and billions of dollars, it seemed like Hubble was going to be remembered as the most embarrassing space project in the world. To add to the misery, the backup mirror made by Kodak was tested and the results showed that it had been polished to the correct shape. If Perkin-Elmer had agreed to cross-examine both mirrors, it's likely that the mistake would have been found before Hubble launched. Despite the Kodak mirror being perfect, it was essentially useless, since replacing the mirror in space wasn't really an option. However, Hubble was specifically designed in a way to be repairable. Located in the back of the telescope were Hubble's 5 instrument bays. Each bay has a box which contains a scientific instrument, allowing Hubble to take various kinds of measurements. This modular design meant that instruments could be taken out and replaced by more advanced instruments throughout Hubble's lifetime. So NASA began working on an ingenious solution that could fit into one of the instrument bays and repair Hubble's faulty mirror. Although the polishing machine had made a mistake, it made a very accurate mistake, so NASA knew exactly how wrong the mirror was. They came up with a compact set of mirrors and lenses that would take the light and refocus it onto Hubble's various instruments. This new instrument, called COSTAR, featured 2 small mirrors that extended out from the instrument. One mirror was completely flat and simply reflected the light onto mirror 2, which was curved in the exact opposite way to Hubble's main mirror. This put the light back into the correct form and focused it onto the instrument. After $50 million and 2 years of development, COSTAR was ready to be launched. On the 2nd of December 1993, the Space Shuttle Endeavour launched, carrying 7 astronauts and COSTAR on a mission to save Hubble. During a 7-hour spacewalk, astronauts carefully worked on removing one of Hubble's instruments and replacing it with COSTAR. It took several more weeks for COSTAR to fully deploy, but when Hubble finally sent back new images, they were incredibly clear and showed that the repair mission had worked perfectly. The scientists that worked so hard to create this telescope were overjoyed and relieved that Hubble could now start doing what it was designed to do. Over the next few decades, Hubble would go on to make incredible discoveries, capturing beautiful images and showing us the universe in a way that had never been seen before. The telescope was regularly serviced by the Space Shuttle, and in 2009, COSTAR was removed from the telescope. By this point in time, the other instruments had been updated to have their own optics built in, so Hubble's original savior was no longer needed. The Kodak mirror remained in storage at Perkin-Elmer's facility until the year 2000, when it was transferred to the National Air and Space Museum in Washington, D.C. Despite never being used, this mirror was in fact perfect, and would have saved NASA millions of dollars and countless hours of wasted time. However, the incredible engineering required to fix Hubble shows just how capable we are as humans. Over the years, Hubble's systems have become less reliable, and the end is in sight for this iconic telescope. New telescopes will come along with more advanced imaging systems, but we will always remember the incredible knowledge that Hubble gave us.